Sarah Kemp over at the end there with the laptop will be speaking in a few minutes and will then lead the rest of the event. Sarah's a local retrofit architect and retrofit coordinator. She set up Eskay Architects in 2004, and Sarah works with homeowners and developers on extensions, renovation and conversions of existing buildings. Sarah specialises in deep retrofit of existing houses, creating beautiful spaces that are healthy and comfortable with low energy bills, so needed at the moment. But she'll tell you all about that shortly. We also welcome our panel, who we will get to introduce themselves in a little while. And there are on the panel Richard and Mary, who are two of our Eco-Open House owners, and Tom Broughton from Solesco, Ben Murdoch from Nuplanet Sustainable Solutions, Sam Bailey, who's also a TTW director. He did the case studies for our Eco-Open Houses event and works for Worthing Homes, and Dave Burholt at the end there from Regen Builders. And Steve is doing the video this evening. He's the chair of TTW. So thanks, Steve, for doing that. Rolf was supposed to be, who's another director, supposed to be here this evening, and Karen, his partner, was supposed to be on the panel, but they've both tested positive today, so are unable to. We designed our Eco-Open Houses event to take place in April 2019, but we had to cancel it due to the first lockdown. We've intended ever since to put on as much of the event as we possibly can, so it's particularly gratifying to be able to put on one aspect of the event that was going to happen in April 2 years ago, and we're most grateful to Sarah and the panel for coming along this evening and helping to make that happen. If you want to find out what else we've managed to achieve this year and other years, do go to the Eco-Open Houses section on our website to see case studies and videos of the various properties and other events. There's a lot on there, so do have a look. If you grab one of our Eco-Open Houses brochures that are dotted around the place, all the links are in those brochures. And if you want to know more about any of TTW's projects and events, you can sign up for our newsletter on our website, which you can do from the home page of the website. This is a free event, and it's so lovely to see so many people here. If you feel you would like to make a donation, and please don't feel you need to, there's some donations boxes dotted around the place. And now over to Sarah for the presentation.
Yeah.
Thank you.
You've all had time to read what's on the slide now. What, why and how to retrofit. What is retrofit? The upgrading of a building to enable it to respond to the imperative of climate change. Retrofit may involve repair, renovation, refurbishment and or restoration. So why retrofit? Well, it cuts carbon emissions and helps mitigate climate change. Saves money by reducing your energy bills and improves the health of the occupants by overcoming poor ventilation and damp issues. Increases the durability and resilience of the building against a changing climate. Improves comfort, drafts are eliminated and heating is even from top to toe. It also creates jobs as we upskill and develop a UK industry to retrofit.
Sorry, too much. Here you go.
So it's important to take a fabric first approach. You first of all reduce the heating required by adding continuous insulation to avoid thermal bridges. These are caused by gaps in the insulation or where the insulation is thinner, or materials such as steel or even timber are crossing the insulation layer and conducting cold into the building. And then airtight construction is important to cut down uncontrolled ventilation. The image shows two ways of doing this, using spray on, or you can tape to stop the gaps. So no insulation without ventilation. As uncontrolled ventilation is reduced, a suitable ventilation strategy is vital. If it's still a bit leaky, your house, or trickle vents and constant trickle extract in wet rooms only will boost, the boost is activated by humidity levels. Or if you've got increased air tightness, you've achieved better air tightness, then a whole house system extracting stale air from every room can be centralised if there's space for ducting, or decentralised with kit in every room. Trickle vents in windows or walls is still needed in this system. But they can be humidity activated as well, so they'll only pop open when required, instead of like a lot of trickle vents that we have in our homes, they're open all the time. If you can attain high levels of air tightness, then that allows for a mechanical extract with heat recovery. It preheats the incoming air and serves every room, and can also remove outdoor pollutants. So measures for roofs. Options for rooms in the roof suffering from overheating and hard to heat in the winter. Insulation between and under the rafters can be installed. This can also provide damp-free storage space. I'm missing a slide, sorry, so if I can get it, there it is. Sorry, this is a cheap and easy option first. There we are. Insulation between and over the ceiling joists to a level of nearly 300 mm deep. And then you'll need boarding to prevent squashing the top layer if you're going to use it for storage. And then we've got the option that I mentioned, which is in line with the rafters. And then the option for the optimum effect is to remove the roof tiles and felt. This is great if you need to re-roof because your tiles are failing. And you can insulate, I'm sorry, where's that gone? This allows you to remove the tiles and insulate between and above the rafters. It's less disruptive, especially if there are rooms in the roof, and it reduces the thermal bridging of the rafters. Measures for walls. Cavity wall insulation. This is cheap and easy if the cavity is not too small. Very sensitive. But it's not for areas of driving rain and wind without a high performance render coat. And we're in one of those areas that's got those sort of conditions. Internal wall insulation, you can see wood fibre on this second image that's been installed on the walls. This is for houses that are listed or in conservation areas where they can't change the facade, or with decorative facades that you want to retain. External wall insulation, shown in the last image, deals well with thermal bridges, low internal disruption, although eave sills and sills do need to be adapted and external pipes need to be removed and then refixed. Measures for windows. So triple glazed windows and doors, much more readily available, and this reduces cold radiance effect. And cold radiance from single and double glazed windows causes a downdraft, even if you've got an airtight house. So they're worthwhile installing. Correct insulation is key. The image shows a cover strip removed to show no cavity closer. It's not very clear up there, but it was just open to the cavity with just a piece of UPVs to stop the weather getting in. Secondary glazing for period windows, but the windows do need to be draft proofed. All the dirt and debris blows in from outside and gets stuck between the two windows. Floor measures. So insulating timber floors, the suspended timber floors, the image shows rigid insulation cut to fit, but in this situation it's not. The airtight tape will not fill the gaps, it will just stop the air infiltration. Expanded foam is required to fill those gaps. Squashy insulation fits better. This image shows some wood fibre or there is a Cubot, which is a little robot that you can pop into a hole in your floor and it will spray foam from below. Insulating solid floors is more difficult. Floors have to be dug out and door openings adjusted. Although I think Dave's got an example of that later on. Although very slim systems are available, and sometimes just cork flooring may suffice. So once you've dealt with the fabric and you've reduced your heating load, you can look at the heating system. And it's air source heat pumps are the most popular at the moment, and there are grants available. 270% efficient compared with a gas boiler that is at best brand new 98% efficient. It goes well with underfloor heating, or larger radiators can be installed to suit the low heating temperatures of 35 to 45 degrees. Other options like ground or water source heat pumps if you have a stream, river or lake nearby. So funding from the Renewable Heat Incentive, payments over 7 years, is to be replaced with a less generous clean heat grant in April. But there is also the government grant of 5,000 over the next 3 years. And heat pumps will be the option for the next 10 years. Hydrogen is not really viable yet. And then if you've got any money left over, you can attach solar PVs. These can provide electricity for the air source heat pump, which is an ideal match for them. It can help with hot water in the summer when the air source heat pump don't do so well. And you can add batteries then for rainy days, overnight, and for power cuts. So what are the easy wins, the things that are less expensive and that you can all do now? LED low energy light bulbs, payback in 9 months, and there's more interesting models on the market now. The ceiling level loft insulation, as mentioned before. Draft proofing doors and windows is an excellent way, is a cheap option and is a DIY. Then polycarbonate and magnetic tapes for secondary glazing has been used, very useful for large historic windows. Sashes especially are hugely expensive to replace. And there's water saving devices. You can fit regulators or aerators to taps and showers. And there's a wastewater heat recovery system now which is effective. It takes heat from the bath and shower water. So what you need to start with is the essential whole house plan. Single measures installed in isolation can lead to unintended consequences. A whole house plan ensures you avoid this and do not block future measures. It can be phased, so work can be done room by room in conjunction with repairs, or as funds or grants become available. Because retrofitting involves a careful balancing of different elements and their effects on the overall performance of the building. A change in one part of the building can affect another, and sometimes this is only apparent after irreversible defects have occurred. It is very important, therefore, that risks are understood and managed in a way that is appropriate to each individual project. Standard solutions should not simply be rolled out without proper consideration. It's vital that care is taken to ensure high quality installations. So where to start and who can help? Try the Plan Builder on the Warmer Sussex website to get an idea of what measures will suit your home. And you can contact a retrofit coordinator who will identify, assess and manage the technical and process risks commonly associated with domestic retrofit projects. Costs and funding. So like buying a car, retrofit does not work if simple payback is considered. There are more green mortgages on the market which give low interest or cash back if you are doing retrofits. They will lend money for that purpose. Sometimes downsizing and using that money from downsizing, you can fix lower energy bills for your retirement. I met one client who had a large house they didn't want to move out of, so they were going to turn the upper floors into a separate flat and then just live in the lower floors. So that was their solution for funding the project. And then you can just, if you have a whole house plan, you can do it step by step as you earn the money. So what I'm working on at the moment, I've got a house in Storrington, and it wants to, we're getting an air source heat pump ready. PVs are already in place, they've had those for several years, but the house is not very leaky, we found out. We've had an air pressure test done, but it's hard to heat, as it's due to poor insulation and thermal bridges. So the solution is to insulate the roof from above, so you don't disturb the rooms below. And external wall insulation, cavity wall insulation, and underfloor insulation. In Barnet, I'm working with EcoFurb as a whole house deep retrofit with low embodied energy materials. And in Parkside in Shoreham, trying to improve thermal comfort and allow hot water pipes in the walls to work efficiently. So that'll be cavity wall insulation, external wall insulation, new triple glazed windows. Okay, and then it's over. Dave, you've got some slides if I can get those up for you.
Hi, anyway, my name's Dave Holt. I'm a director of Jove Group. We've got 3 different subdivisions under us. We've got a carpentry division, an eco-electric division that mainly does EV, electric vehicle hookups. But we've got a renovation group that's been going for quite a few years, and we mainly do up old houses in Brighton, really. Lots of listed buildings. And they all have a lot of people want to upgrade the thermal efficiency. Many of the techniques, as Sarah's discussed. So we've sort of developed our own techniques over the years, and we're hoping they're going to become quite a standard, almost like what you'd call a typical detail. So this is one we do a lot, where we remove all the plaster and can you hear me? Where we remove all the plaster often. A lot of buildings we work on are a good 100, 150 years old. A lot of the plaster is so old and knackered, basically. It's delaminated, it's all falling apart anyway, so you often have to re-plaster anyway. They're lath plaster, so there's quite a lot of depth to them. They're on battens. So the technique we do is we remove it all. We put what's a metal furring system, which you can see there, and on top of that we fix normally a PIR board, which is Celotex. Though sometimes we do the wood insulation you can see up there, or we use wool like this sometimes, but it's, to be honest, a lot more expensive. And then we plaster over the top.
Sorry, are you talking about inside the house or outside?
Yeah.
This is all inside.
Inside, right.
Yeah, so, sorry, yes, because they're listed buildings, we cannot touch the outside, and even a non-listed building, I mean, the one you're doing, are you able to do the front of it, or?
Oh, and
The one in Sterling, or?
no, yeah, none of them in conservation areas or listed, so
Yeah.
I'm all right, but I have had situations where listed buildings and we've had to do it on the side, yeah.
Yeah, so, anyway, yeah, so the techniques I'm showing you, they just do on the inside. And this also allows the walls to breathe, which is incredibly important because they're often a lime mortar. And the problem with that, it's been found, is that has to stay moist. If it's insulated too well and too airtight, and you were talking about ventilation, weren't you? It just dries out, and the whole wall will just slow, the mortar will collapse. Brighton has what you call bungaroosh in it, which I don't know if you've heard of, like a rubble-filled garbage, and it will just trickle out. People will have it trickling out their sockets and stuff because they've had a very good render on the outside. So this technique with a breathable render on the outside allows the walls to remain slightly moist, and they keep their integrity. So yeah, that's the drawing I found on the internet. So there's, if you can go on. Oh,
Do you want to, I think you can, give you just a click on there.
there you go. So this is a listed building we did in Palmyra Square a few years ago, and it's the flat up there that you can see. And when they bought the flat, they thought the ceilings were about 2.5 metres high, but they found up above them was a whole 2 more metres. There's massive rooms. And in working with English heritage and stuff, we removed loads of the mouldings and stuff. We insulated behind it and then put it all back. It is expensive though. There's just sort of no two ways about it. But then having properties like this are, so how do I move on?
Just
So-
click the padding there. You should just
What's that there?
Yeah.
I've done this before. So that shows the walls stripped, and then it has the metal lard on it. It's called MF10, and then that's the room finished. And yeah, so it is a lot of effort, but I think it's the only way to, well, otherwise you then have the property that's not warm enough and it's not efficient. And, yeah, there you go.
It's a huge room as well, isn't it?
That's a massive one. That's just part of it. So again, this is another property in Brighton. This is a 1920s house. And again, you can see the walls stripped with the MF10 system on it. This we did with Solesco. So that's 40 millimetres of it there. We put that on first and then we plasterboard over the top. And that's a kind of a cheaper method because we're not using, in the previous one it had to be all lime mortars and stuff like that, which are very timely and expensive. So, and that is the rooms finished in that one. So this is after it's been done. So the idea is to make it look like it did before. So we save all the mouldings and we get them dipped, or we. The only thing we can never save is the coving. We have to get that remade. So another technique we use is to try and create a thermal block in the middle of a house, or normally on the ground floor. And a really good way of doing that is having a very well insulated slab with concrete or screed in it with a heating element in it. And if people have solar panels, sort of part of the problem with solar panels is creating energy when you don't need it, and it can get fed back into the main system, or people can have it in batteries, or you can stick it in your car, which is a good one if you've got an EV vehicle, or it heats a big lump of concrete, a thermal mass in the middle of the house. So this system is a block and beam floor. So you take up the floor, you put in the beams, which are the white things, and in between them is insulation, and then on top of that is more insulation. Then you have the screed that has a heating element in it. And this is relatively pricey. It's probably cheaper than doing, well, it's difficult to say, to retrofit a solid floor where you have to dig down already. But if there's already space there because you have a suspended floor, it works quite well. You have access underneath it for all your services and things like that. So this is one we did. So that's the original hallway. Again, a 1920s house. That's it all dug out there. We had to suspend the stairs, so you can see the first beam going in underneath. So this is, we didn't have to dig it out particularly deep. There's normally a space like that under most buildings, modern ones, whatever ish one. And then that's it, showing it looking pretty Yeah. And then, so this is the system going in with the insulation in it, and then it has the screed on it. And then on the screed we put what's called a decoupling mat, because it's going to be tiled, and in that screed is a heating element. The decoupling mat stops the movement, because you get a level of expansion and contraction, and the tiles will crack, they'll move. So it's quite a newish thing to do that, but it does work very well, especially over large areas. And these are the tiles going down, and that's it, finished and done. They were designed by a company from Antwerp, and they're handmade in Morocco. These encaustic tiles, so they're really thick as well, so they hold the temperature. And yeah, they report that this takes.
I'm sorry, I've got to
it takes several days to get fully to temperature, but it takes days to cool down. And again, that just heats the core of the house. So in conjunction with PV, with photovoltaic panels, on a sunny day in the winter, that energy will just go straight in there and just store it. So yeah, so there's that.
There's a cooling core in the summer. How does that work?
So because it's a bit like in continental houses, they'll have like a marble floor and that, and in the summer it just remains cool,
Right.
because the ambient temperature is cooler overnight, and it's just this nice cool, which I think we're going to have more of, aren't we? I think these sort of hot summers and freezing winters. So this is another technique similar to some of the ones Sarah was talking about, for heating under the floor, and this is quite for insulating it. This is fairly easy to achieve yourself. The friction fitted Celotex is kind of good, but it's only as good as how well it's done. And as you said, you can spray between it with builder's foam, and that hits the gaps. But if there's any gaps in it, you get a thermal bridge, and it's no good. So this technique is where you take up the floorboard, so it's a suspended floor, and between it we put a geotextile, the same stuff is used for to stop weeds growing through, and it's draped in there and stapled, and then we fill it with either a vermiculite, or there are other products as well, and there's the granular cellulose. You just pour this stuff in, and it's got a really good thermal index, and because it all just settles there and it's completely inert, it fills the gaps really well. And then you finish the floor back over the top. It's technically very, very easy and very, very efficient. You've still got to have ventilation underneath, but it enables that. And it's worth treating the timbers before, because modern timbers are pressure treated, so they can put up with woodworm and stuff like that, but there is concern some people have with this because of the lack of ventilation in the timber itself. It can encourage pests and, you know, like woodworm and stuff. They like warm, no air. They like it. So yeah, you just treat the timber first, and then that's the room done with a structural oak floor. So it's just an interlocking oak, solid oak stuff, which, yeah, we used to get from Northwood Sawmills up the road, which they closed last year. But they would only get their oak from local trees. The farmers would have a tree fall down, they'd call them up, and they'd drag it off and turn it into these lovely floors, and it was really cheap. And you know, very good carbon footprint on that. And I think, yeah, that's all I've got. Yeah, so there you go. So, thank you.
The depth that you've got there, so you've got you've insulated the void underneath, and you've got a depth of what?
Which one are you talking
When
about?
you've got the, you've used electrical.
The block and beam floor?
Yeah,
Yeah, so the beams come in two different sizes depending on what the span is.
yeah,
One 150 mil and 225.
right,
And then the thinnest screed you can have, conventional one, is about 70, 80 millimetres. So you need the insulation as well. So you do need a fair depth. Really, you'd need a dig out of about 400 mil,
yeah.
so that there's a bit of air gets in underneath.
Yeah,
But it's actually a simple system
yeah.
to do as well. There's nothing particularly difficult about it. You just get these beams, plonk them in, these very lightweight. The sections that sit in between are like a T shape.
Yeah,
You just cut them with a
yeah.
kitchen knife. It's,
And you've got insulation underneath the beams.
it's insulation within the beams, then on top of it if you want to, and that gives you a very good U value.
Right.
And then you can either concrete on that or screed on that, and that is where you would put the heating element.
Right.
And the reason that one took so long to heat up is because the heating element's right in the bottom, and it is to heat this big lump.
Yeah.
You can put it just under the tiles if you want a quicker response, but it doesn't. I mean, it will slowly heat up the concrete, but not as.
Yeah. You've got more in the spread, don't you?
Yeah, exactly.
So the actual heat store bit is about 18. Sorry, so you've got the beams, you've got the beams in, you've got insulation, and then on top of that you've got the screen.
This had 100 mil, and then it's got the tiles as well. So it's got about 120 mil of
So that's
solid.
That's the heat store bit.
Yeah, because they're encaustic tiles, so they're cement based essentially. So. Yep.
Can this be done in flats? Can you retrofit flats if other flats around you aren't retrofitted? Is there, or is it just impossible to do some of this stuff and it be worth it?
The first example was in a flat. It's definitely worth it. I mean, I was thinking about that Letty thing. There's a lot of flats are actually thermally very good because you're sharing each other's warmth, aren't you? And it's all to do with the external walls, and it's really to do with what's exposed that needs to be dealt with, unless your neighbours are, ridiculously. So it's certainly worth doing. And on a flat, the examples, the thermal stuff we did on the first one, the Victorian one, were only on the external walls. And because that's down on the beach in Brighton, it gets a real kicking from the weather. It's just dreadful, which is why they were really keen to do it. So, yeah.
Sorry, I'm trying to get a slide up of the panel, but I've lost it. Maybe I should just... Do you want to all introduce yourselves again so that questions can come
I'm
in?
just going to say, is there anything else that you
I work for Worthing Homes, a local housing association. My role there is as Sustainability Officer. But as Pauline mentioned, I'm also a Director of Transition Town Worthing. And I used to deliver energy projects for TTW. That was mainly energy efficiency. And,
Excuse me, can you speak up, please? I can't hear me. Thank you.
how's that? Any better?
No, very good.
So we mainly delivered energy efficiency and tariff advice, as well as some fuel poverty intervention. But we also had a skills sharing program called SNUG, which was concerned with draft proofing. So that's what I'm here to answer any questions during the Q&A tonight about. Draft proofing is a low-cost, quick-win approach to reducing your home's fuel consumption and carbon emissions. And it will help you to stay warm and comfortable and snug, hence the name. It's in keeping with the fabric-first approach to retrofit, which is favoured in the industry, and with the nature of the housing stock in the UK, we waste a significant amount of energy through drafty homes, and it's applicable where financial or planning constraints might prohibit more extensive measures. So it's something that's accessible to a lot of people and cumulatively it can make a big difference. So if you want to find any further information, the Energy Saving Trust has a really good guide on draft proofing, and that's at energysavingtrust.org.uk. Thank you.
Good evening. I'm Ben Murdoch from Nuplanet Sustainable Solutions. I'm a sustainable design consultant currently. I'm also an architect and a passive house designer. I've got a keen interest in retrofit. We're looking a lot at the modelling of houses pre-retrofit currently, so using tools like SAP and PHPP to get as accurate a picture as possible rather than just using RD SAP. I've done some work with Warmer Sussex, which I won't share, and that's it really. I'm here to answer any questions you may have, whatever we can do to help get you started, or if you've got certain concerns, how to avoid unintended consequences, how to look at thermal bridging, what are some rules of thumbs, all sorts of things like that really. So thank you.
Yes, hello, my name is Tom Broughton, Director of Solesco Community Cooperative based in Chichester, Arran area. I'm also a Director of a solar farm, a Meadow Blue solar farm between Chichester and Bognor, which is a community-owned solar farm. I've been in the solar business since 2010. Been stung very badly twice by the feed-in tariff changes. Feed-in tariff's gone totally now, but it's still worth doing if you've got a good roof facing in the right direction. It's still worth doing financially, and of course it's definitely worth doing from an environmental point of view. So if anybody's got any questions about solar, please ask me.
Hi, I'm Mary Curd. I'm with Richard Batson. We own a mid-terrace, 1930 built, retrofitted home in Broadwater, Worthing. That happened 10 years ago? About 10 years ago. So what? I'm not sure. Well, so we've been living with it and used to the experience now. For 10 years.
Yes, we still find it very cosy. We haven't had any damp problems. So, you know, thumbs up for it. It was, our main thing was to improve the insulations considerably, but only use material that is biodegradable. We didn't want to use any plastics or anything that's got a large carbon footprint to it, any concrete, anything like that. We managed mainly to get rid of plastics, not entirely. So we had our walls done with wood fibre insulation, and there's an example there, 60mm at the front and 80mm at the back. The difference was the front, we had it inside because we had a mock Georgian front which we didn't want to disturb. What? Tudor, so I was here. What's in the name?
Only a couple of centuries.
Yeah. And at the back, the rendering was falling off anyway, so we had it out in the outside. And it was plastered over with lovely lime plaster and lovely lime rendering on the outside. Beautiful to smell and look at. And it's livable. It moves. It does get damp and then dries out. But damp doesn't ever get back into the inside of the house, which is not that we know anyway. And in the loft we had the recycled newspaper insulation put up there, and that was, well, the legal thing was 300mm. I only measured it today. It was actually about 350mm he put in. We still wanted to use the loft, so we did a very simple thing. We put the insulation down, we put 100 by 50 joist that way, put more installation down and put 100 by 50 joist that way, and then we relayed our flooring that we'd got for recycled flooring anyway previously. So that was how we did that. We had to have our windows. It's a shame because the windows were lovely, but they were leaky. So we've actually reused them as a greenhouse in the garden. But we had new windows. We wanted wood again because biodegradable. So we got triple glaze, argon filled wood windows made in Bolton, FSC wood. We tried to do as much as we could in our ethos. We had an architect to design it with us, Ecotexture from Haywards Heath. Quite a challenge, and we also selected a builder that lives in near Sorington, and he was quite a challenge, but it was a nice challenge. And we lived in all this time, sometimes under polythene, because the trouble with lime plaster and lime rendering, you have to let it dry out slowly. And so we had polythene to stop the rain. And he said, no, we can't have polythene. Yeah, you've got to have polythene. Okay, we'll have polythene. So we lived behind that for about the hottest summer of August, unfortunately. But so that's ours. We didn't do the floor. We got ordinary non-tongued and grooved flooring. We've had a lovely carpet. We didn't want to chuck things away that still had a good life to them. We will do it possibly eventually. And in the kitchen and bathroom where we just got floors without anything on top, I just filled all the cracks with brown paper and PVA glue. Simple. And put some eco sealant over the top, and that's worked. And again, we've got a boiler that was installed 15 years ago. It's still working at 98% or 97% efficiency. So, you know, do you replace something that's still working? No, not at the moment, but we will do when it eventually gets down to a lower efficiency. So that's really our whole lifestyle is trying to tread lightly on the earth. So we everything we do, you know, in the garden, in our shopping, in our is to try and use and as least carbon as we can, and the foxes still come around, and we enjoy the foxes in the garden. So that's us. Thank you.
Great, that's brilliant. Thank you, panel. So we're just going to have a short break now. Just gentleman over there.
Hi, my name's Kieran. I own a 100-year-old Georgian house in Durrington. Wanted to get on this journey for a long time, but haven't really worked out how to get to start. So I've had quotes for solar PV and batteries and air source heat pumps, which I've not gone ahead with. Trying to work out the best way to. It sounds like I've come to the right place for a start anyway. What would you say is the best way for me to start the journey? And it sounds like there might be somebody on this panel, or at least people on this panel, that I could talk to give me like an overview of or an assessment of the house to see what the best first measure is to do within the house as it stands at the moment. Thank you.
Ben, do you want to?
Thanks.
Because it's all about assessing and
Hello.
the whole house plan.
I would say the.
Just in case.
Thank you. I would say one of the first things that you should consider doing is getting the house assessed. Whether that be there's various different methods to do it, but have a retrofit assessment for your property. Find out what's good, what's bad, how thick are the walls, is there evidence of damp in sort of lack of ventilation, things like that. And then from that, once that's sorted and done, is then start developing a retrofit plan for the property to take you from now, where it's performing relatively badly, I'm guessing, through to something that's a lot more efficient with, say, like the air source heat pump. Because at the moment, if it's not insulated, an air source heat pump is not much use to you.
Well, exactly, yeah. We've had a loft conversion done, so the roof has been insulated and it's got a flat roof up there now.
Okay.
Which helps because it's northerly facing, so we could potentially put solar up there. That's a bit more costly than doing it on a single eave roof.
Yes, I think the assessment would be the easiest way, because then what you can set out everything and test various different measures. Whether it is a 100-year-old house, so is it conservation area or a listed building? So you could look at external insulation, which is one of the best ways to insulate your house, because you're wrapping it in a tea cosy, and you're covering up all of the cold bridging, all of the gaps, and you're making it more airtight and more thermally efficient. But my suggestion would be get the house assessed, and then either speak to, I'm not doing the design so much anymore, so speak to Sarah to start developing a retrofit strategy for how to take the house forward, and talk about whether you need planning permission for anything, building regs, replacement windows, etc. And have it set out so you can have a series of phases for what's the first thing. And then once that's done, you don't need to undo part of that to do the next bit.
Well, that's my concern is I go straight in and buy solar PV and a battery. What am I going to use that for if the house I've got no underfloor heating to use, or who do I speak to get an assessment? Stupid question.
I know it'd be myself or Sarah. I think you said the Retrofit Academy have a list of retrofit coordinators, or an architect that you might know, somebody within the area where you live.
Yeah. Okay. Thank you.
And there's two sorts of assessment that we do, and there's something called the target assessment, where you just go and look at the house, and we do some rough plans, and then you put it through a program, which gives you a whole house plan. But it's based on very standard information. So the other way is to model it in PHPP, which is what Ben does. So that's a bit more accurate. It's a truer picture of your actual house. So that's, so there's two methods, and that does involve having the whole house measured and drawn up. So there's two ways to go about it. You just need to, which is more suitable.
Okay.
Any other members of the panel who want to?
Can I just ask how much this costs, roughly speaking? Because that's one of the big barriers for people who are kind of
sniffing around at this?
Depends on the house, sorry. It's a case by case. Yeah. I'm trying to get some standardised, but until that's quite difficult. So it'll be on a case by case. All houses, every house is a little bit different.
But are we talking sort of starting at a sort of £1,000 type level, or are we?
Yeah. It is, I think the modelling I've just done for a 3-bed house for Sarah was £1,250.
Yeah.
I think £1,250, and that gave us an overall picture using PHPP. So we can use PHPP or SAP. SAP is UK building compliance software. PHPP is design passive house software. That's slightly more pessimistic than SAP, which is slightly more optimistic, but using those two methods we can get a thorough understanding of your house. But yeah, that would be the assessment. If you don't have plans already of your house that we can take measurements of, we'd need to either commission a survey or do that so that we can build the model in the first place.
Anybody else in the panel want to comment on that?
I was going to ask, do you do thermal imaging in any of that, or is that purely assessed on a visual and?
So that's our modelling assessment.
Yeah.
In terms of what physical assessments are required of the building, it depends on the building. We would typically, an air test is a really good indicator. So because it gives us an idea of how much air your house is leaking. Thermal imaging is great, but it's restrictive to do the entire assessment because we need to do it in winter with the wind coming in from the southwest, and we need a set, I think it's 20 degrees between the inside and the outside, so it can't be done in the summer.
And it's got to be dry.
It's got to be dry. But we can, Sarah and I have been looking into using the little thermal imaging cameras, so you get the plug in through the phone just to look and pick up
missing insulation, cold bridges,
defects that if you sort of come to us and say this room's cold, we can have a quick look and say, well, that's probably wrong. So a full thermal imaging wouldn't be included in it, just because of the practicality.
It'd be interesting, Sam, what are you doing with your houses? Because you have a whole stock of houses in Worthing. What are your assessment procedures?
We use the data from SAP, or mostly RDSAP, and put that into some modelling software.
Chrome, is it? Or?
Yeah.
Yeah. Okay, so that's.
It's now called Parity Projects.
Yeah.
Yeah, that's what we're using to model the whole stock.
So that's the target method rather than the passive house.
You just wanted to make a comment about this same thing.
It's building actually on the point you were making, I think. And earlier on you mentioned about the concept of a whole house plan. I'd be interested to know what that looks like from a layman's point of view. And also linked into that, there was you said there are certain within the planning process that you'd undertake, there are certain works you do. Well, there's an order of works basically.
Yeah.
And if you don't follow that order, there's a danger that you may make structural mistakes, etc. So could you build on that at a practical level?
So part of the whole house plan is an order of works that sometimes can be moved around due to. So there's two parts to a project. So there's the order of your measures. But within that, you've still got to, let's say you're raising a roof, so you've got to go to plan. You need planning permission, and then you need building regs, which they want to know about structure, they want to know about the insulation. They'll come and inspect while you're on site. That's all got to be passed as well. So, yeah, and then the builders might want extra details to help them understand. So maybe an add-on of technical information that we need to create to help the builder. And then if you're a retrofit coordinator, you're going to go on site and take pictures and record particular critical details to know that they have been done properly. Yeah, airtightly. It's just a set of critical details that you would have decided on before you go on site. And then there's once you've signed off, it's nice to do a post occupancy and come and check up on you, find out how it's going. You're managing to, have you been handed over properly? You're managing to, all the systems, are you managing to operate those properly? And are there any, there could be unintended consequences. Things aren't quite working and just need to be looked at. Yeah, just making sure it's.
I just wondered if Tom could, I know Tom came round our house and did a thermal imaging exercise right the way around our bungalow, and we found it incredibly helpful and absolutely fascinating. So I don't know if you want to just quickly say something about your experience with doing that, Tom.
I think, to be honest, thermal imaging camera is a great way of starting a conversation with the household owner. I think, as Ben was pointing out, to do it properly requires very specific conditions, but things like defects are very, very obvious. And you've got to be aware that sometimes, because windows reflect, and sometimes you get misreadings because of the reflections of surfaces. I think it's for creating a conversation rather than an analytical device, personally.
Thank you. Okay, there was a lady up the back who asked first, so, and then you Caroline, in a minute.
Yeah, I'm just looking at the air source heat pump.
I'm sorry, could you take your mask off and stand up, please, so that we can hear what you're saying?
The air source heat pump on page 28 of this booklet. It's quite big, it's much around the back of their house. My question is, if you can't get round the back of your house, and where you could put it might impact your neighbour's views, you have to get planning permission or anything like that. But do they actually make any noise?
Well,
yes, they do make a noise. There are some strict requirements for permitted development for the location of your air source heat pump external unit. It needs to be 1 metre from the boundary. It needs to be on the rear or on the side. It can't be on the front, and it needs to be on the ground. If your neighbour can see it from their window, that wouldn't really be a material consideration. You, as part of the sizing process, so the assessment of your house, where we would size your air source heat pump, we would undertake certain evaluations of what the surrounding materials would be behind that heat pump. So if it's surrounded on 3 sides by brickwork, that's going to reflect the noise more and could cause disturbance to your neighbours. We'd also have to do an assessment from I think it's the centre of the air source heat pump to the centre of the closest window on the neighbouring property to assess noise. It's mainly noise impact. But if you meet those requirements and there's a requirement rating for the noise of the heat pump itself, then it should fall under permitted development.
Okay. Caroline?
Yeah, it was just a comment. I was just thinking that for most people, if they had an EPC, like an energy performance certificate, that's 50 quid, and they will give you a basic idea about how energy efficient your house is, and give you some ideas about the sorts of things that you could do to make it more efficient. So that could just be a first start before you then go on and decide that you're going to do some other things. So.
Thank you.
Can I?
Sorry?
Can I?
Yeah.
Funny enough, we are doing some assessment on a couple of properties up in London, and we're doing it under PAS 2035, and the basis of that uses RD SAP, which is what you use to create the EPC. What we've done is we've taken it one step further and we've modelled it in SAP, which is the sort of next step up from RD. RD SAP is reduced data SAP. So we then use SAP. It's all based on the same software. And we are getting, I think under the RD SAP, we were getting something like a 56D, I think 56, but anyway, about a 56D, but then under SAP we were getting about a 50. So we're getting a lower result because we're putting in more information. So whilst there is some benefit in using the EPC, it's based on RD SAP, you need to be aware that it's not taking full consideration or giving you a fully accurate picture of your house. It's very much a snapshot.
For avoidance of any doubt, we'll still between 50 and 56. Which way's good?
The higher the number, isn't it?
Yeah, the higher the better. Unless you're doing a commercial building, then it's the opposite way around. But I don't know why.
I think it's just a good place to start, isn't it?
It is,
yes. Because it's 50 quid.
Yeah.
Dave?
I think the starting point for a homeowner is I agree with myself, using the EPC, which is what I've done, and I purchased the house in spending in 2013. It was a D, I think, and it's now A96. And that's all done on my own initiative. I didn't get anybody to spend lots of money on surveys. It's just using the EPC and seeing what things need to be done. Upgrade the loft, coaty walls, already had the solar PV, and then just progressively over the years, last 5-6 years, done all these things, so it's jumped up quite dramatically. I'm the only house in the BN44 postcode with an A rating, all done by myself, and used to hire people to do the things. And so you don't need to think about, from my perspective, I didn't think about SOC pumps, I didn't think about solar panels. It's getting the infrastructure right. When you've done all that, then you can get spend money on other stuff. So that's my personal feeling on that.
But you have got experience of dodgy EPCs, haven't you?
Oh yes, I did. When there was this free government cabin wall installation being offered, British Gas were offering to do a survey to see if it qualified, and I did. I think bloke said, "Can I have a look around your house? And can I go up to the loft?" And I said, "Yeah, no problem." So off they went, and I decided not to have the British Gas, because it was foam, I think, and I didn't want foam installation. About a year or two later, I looked online to see what my EPC was, I couldn't remember. And the British Gas guy had done an EPC and posted it without me knowing. And he'd made lots of mistakes. And so I could have gone back, I didn't bother about it, but I saw his errors in what he did. He said there's no thermostat in the tank anymore. LED light bulbs, he said it's 50%, it was 100%. So lots of small things he'd overlooked. So if you get an EPC done, you need to be careful with it.
So would you get a heat pump?
No.
Why is that?
Because I've got a A-rated 96 with a system boiler, so I spend £15,000 waste chucking money in the drains. No point.
How would I get an EPC done? How do I sort that?
That's a good question.
There's lots of them out there.
Need to contact a DEA, which is a domestic energy assessor.
The DEA?
Yeah. I could plug a company. It's not mine.
If you, I did it today. If you put EPC Sussex into the internet, if you have the internet, you'll get a list, or you can go through the government website and it'll say these are the people who live near you. Sorry, these are the people who are working near you, and just put in your postcode and it'll come up with a list and you can email them directly. And there's lots of people locally.
And would you say that's a safe way of doing it?
They're all registered with an accreditation board, aren't they?
Yeah, they are, but
So-
there is. You can also get them done from abroad, where the assessment seems to be done by Google Earth. So it is a matter to go for a local company.
Yeah. You can look them up.
Yeah. Or if you want, I can give you a name later, if you want.
I do have another question. We live in a drafty, late Victorian, semi-detached house. And we have limited means, but one of the things I'd like to do is work on the draft proofing. Any suggestions where I could start? We have no practical skills.
Sam, do you want to pick that one up?
I mean, you can do it yourself with little practical skills. You can do it yourself. You can do it yourself with just a small modicum of practical skills. And I mentioned the Energy Saving Trust website, energysavingtrust.org.uk. They've got a lot of good resources there. So it might cost you, say, in the region of £50 to £75 to do it yourself, because the materials are fairly cheap. Or you could get it done professionally, which might cost more, in the region of £200, but you'll likely achieve better energy saving results doing it that way.
Right, so if I got an EPC done, that might indicate where we would need to target resources and which expert we would need to be involved, because you couldn't afford to retrofit it. I mean, that's crowd cooking out in terms of our finances. So we need to think about what can we do in terms of the money that we've actually got. No. Yeah, well, it's good to know about the energy saving. That's the website we can look up, and the EPC.
You could walk around the camp where you find the draft.
Oh, I don't know.
I'll just say that David bear me out, if you are going to get an EPC done, if you are getting an EPC done, get your ducks lined up in a row before. So if you have any work done, make sure you've got evidence of that to give the EPC chat, because quite often they'll just put down what they think. If something's not obvious, like insulation, they will put 20 millimetres assumed when you've got 100 millimetres.
I mean, when we had our EPC done, he gave us a draft, and we were able to point out this isn't right and that isn't right before he actually published the final thing. Hopefully they'll still do that.
Yeah.
Thank you.
Yeah, my name is Mike Dixon. Several months ago, I was on a Zoom meeting with the New Economics Foundation in conjunction with the Centre for Alternative Technology. And the scale of the problem in the UK that we've been discussing this evening is massive. One, it's people haven't got the money to afford, most people haven't got the money to afford these kind of things. And also the workforce, the New Economics Foundation, we're looking at a total lack of skilled labour here in the UK. You know, have you got thoughts on that? How have we got enough skilled staff? And if not, how are we going to improve it? For me, I think over the last 20 years, things like national vocational qualifications have been played down, and we put people into universities and money into university training programs. But it's people who are on the ground doing these things, the carpenters, the brickies, the electricians, the plumbers. It seemed to me, and I don't know a lot about these kind of things, but it seemed to have been a lack of, or a reduced amount of training available for these people. But now, with this and the Green New Deal, we're going to literally need millions of people to do this work, and they're going to need to be well trained and supervised.
And there needs to be a national programme. And I have talked to our local MP, and he'd rather do it regionally, he said, which is not what we need. A national.
Can't hear you.
Sorry.
Can't hear you.
Oh, sorry. We need a national programme. It needs to come from central government. We need funding. I think there's been a request, the ACB mentioned something about they are asking for stamp duty so that you'll get reduced stamp duty if you've done work, and the people who haven't will get, so there'll be an income from that. I think they're asking for that to raise some money. Yeah. But it's a massive problem. It's too expensive. We don't have the workforce. We don't have the skills.
They're talking about 15 million people in the UK that cannot afford to pay their day-to-day bills, let alone all this massive work, which I think everybody in this room would agree that this is required, especially after the political failure of COP26. And that was partly because the fossil fuel industry had 400 representatives, if not more, at COP26, getting all the kind of politicians and their civil servants, to sit on the fence and not make any decisions.
I think this is why I get a bit fed up waiting for government funding, effective government funding, and just little things like you've trained people up to do the draft proofing. That is what we've got to do, and do what we can, learn to do things ourselves. If we can DIY it, if you're capable, then that's what I. There are training programs that are popping up to upskill the labour force. I've seen 3 recently. They're small and they're all in the north. I think I'm just going to move up north. But they are starting to grow slowly. Just got to remain optimistic.
On that note, and I don't want to necessarily dive into politics, but do you think this
Could
current...
you stand up and speak into the audience?
Do you think this current government have any commitment whatsoever to support any of this?
I think I'm going to take the XR attitude that we've got to work with whoever's in power and remain apolitical. So I'll keep. I've still got a right to letter to Tim.
Take the fifth.
I think that they've all been collectively guilty of ignoring the problem. It's so big and it's been around for so long, we just haven't done anything. But whilst we need a national programme, where we're here trying to do it ourselves and sort of taking the lead, as it were, we need to work together more closely, and it's about, I said earlier to Tom, that it's about more collaboration. So architects, designers, energy consultants and builders, we all need to be working together, and it's what we need is to change how we're thinking about it, rather than thinking this is how we've always done it. And say, well, that's great, but this is how we need to do it, and we need to take that approach on a small scale to start with, and hopefully you're sort of showing what you're doing, and you're training people that if and when they go and they move on to another job, they're going to hopefully take those skills with them, and it starts building from there. I think it's the only way it's going to get done. We can keep asking for a cut in VAT on retrofit, but it needs to be linked to standards, because otherwise it becomes an easy tax.
All the time it's cheaper to knock a building down and rebuild it because of VAT. There's no VAT on that. So everything you're talking about, saving the planet, you're not getting reward. You know, there's the grants and that, but it's still a pretty rich man's game to have PV and all that. You know, you've got a bit of, and the air source heat pump, you know, the outlay on that, the initial, what's that, 14K or something, is it? The standard system. And most properties, it won't work in them. They're not thermally good enough. You don't have you can't site it somewhere for starters. It's just difficult. Yeah, we've got one apprentice who wanted to do just retrofit stuff, and as you said, the only course is, I think there was one in Vauxhall.
Well, they've got one in Harrogate now.
Yeah, and all the rest are...
One in Manchester, and there's 2 places in Ireland. I mean, Ireland is Streetnet. They've got 2 centres where...
What about the passive house course, or the passive house tradesman, or is it a bit...
Well, he looks at that, or he can look at being a bricklayer and earning 200 quid a day. And it's just
tough choice.
And you know, you could do all the training, and then what are you going to be able to specifically do with that? There's the massive need, but not the, I don't know, there's not the will with building control. The other thing to do would be to make it a requirement of any building standard that the grades are put up, which sounds like a really good idea, but it makes the building more expensive. You are ending up using techniques like I showed, because on the one hand you've got to conform to planning and conservation, and then they're going to force you to upgrade the thermal efficiency of a property. How do you do both without serious money?
I do think when it starts to really roll, it will get cheaper.
That's
because
it will get cheaper. Yeah.
The materials we want to use will be more available. They'll be in Travis Perkins instead of
definitely.
in Wales and coming on the truck. So
Sarah starts as part of my question about the more volume that comes online in terms of demand, it will gradually bring down the price of materials. The other part of my question was, if people organise themselves like street by street, community by community, to what extent would that bring down costs for individual households that were part of that?
that would help, because you're doing multiple houses in the street, especially if they're terraced, or that makes it a lot easier.
So a bit like Solar Sussex, or whatever it is, you can amalgamate lots of houses, lots of people together to buy. I mean, what is the cheapest way to buy solar at the moment around here?
Wrong question.
Yeah, is it?
Cheap means not very good.
Okay.
Okay, a good value. Well, good value.
Yeah.
And CC Solar are based in Littlehampton, and I looked at their website today, and a 3 kilowatt system they'll charge £2,900 for. And I think that's probably not the full cost, because scaffolding would go on top of that. But I think a 3 kilowatt system, electricity prices, what they're going to go. I mean, today I did a quick check to see what they would be. You can't get a contract with a supplier now at the default tariff, the price cap tariff, which is about, for electricity, let's say it's about 22.4p, and the cheapest I could get was 35p for electricity. The cap is going to be announced soon for April. I think there might be have to be some jiggery-pokery, and the energy companies might have to be lent money to spread out that cost. But I think it's showing the direction of travel with electricity prices. And already I'm finding that the wholesale prices that are being offered to solar farm owners are already creeping up for 2024, 2025. And so I think prices are going to remain high. So let's say 30p a unit, I think you could probably, let's say £3,500 system, you could probably save and earn about £500 a year. So you're talking about, and you are doing a lot to the environment because you are producing very low carbon electricity. I think it's one of the problems we have definitely over in Chichester is at the moment is we can't connect large scale renewables to the grid because the grid is full. And we got the solar farm I'm director of, it's 5 megawatt solar farm. We want to put a 2 megawatt extension on there. We can't get electrical connection until 2024. And so, but then if we had 2 megawatts of domestic scattered around the grid, that would be fine because it's scattered around the grid. And so that's why I think we all need to put solar on our roofs so we can because we're going to need that energy. We are going to have heat pumps, we are going to have electric vehicles, and we're going to need to have the electricity.
Thank you.
I think Jeff, you were next.
Oh, myself, sorry, I think. Solar panels, what are the restrictions in conservation, or is it grade 1, grade 2? What are the restrictions?
If it's on grade 1, grade 2, you need planning permission. Conservation area, if it doesn't face the road, then it's fine.
Just a thought here. If you've got a building that's listed, or you've got a tricky old roof, but you've got a decent sized garden, and you're able to do it, you can put up something like a log cabin. I know I've done this in my garden because I've got a system on my house and I wanted to get some more. And to put up a freestanding system, you need engineers' reports on structures, and you need planning permission for anything more than a tiny amount. But if you put up a log cabin in your garden, certain limitations on that, but you can then put a decent sized system on a log cabin. Which can work quite well, and you've got a useful little building as well.
Also, if you're in a conservation area or listed building, if you've got a large outhouse or a garage, and if the garage isn't listed, then you put it on the garage.
Can I come back to the question of kind of finding a builder? Because in our house in Stending, we had a kind of eco-design job done. It was probably about 7 years ago now, and a very detailed spec, and with loads of kind of background documents on the materials that they were looking for. And we put this out to a whole load of local builders, and they wouldn't touch it. And one guy said, "It's going to cost me 70 quid to print it out, mate," because it had all of this kind of eco detail behind it. And we ended up going for a firm in Brighton, which is quite well known and was kind of in this game. But nowadays, I'm wondering if we did the same again, would most builders be bidding for this work, or would they be steering clear of it because it's too complicated?
Well, we often, the role of an architect is like a manager as well, like a project manager, like a producer, and they will often manage that section, like with contracts. But also we often do stuff where there's a bill of quantities and it'll be very defined in that. And from a homeowner's point of view, this bill of quantities will have a very specific, 10 square metres of wall with whatever insulation in it. And it breaks it down, and it works quite well for the builder as well, and it works very well for the client because you can very much compare like for like. Because often, unless you have the skill to look at the quote you've been given, and if it's one big lump sum, you really don't know what you're getting. and a lot of builders will not bother with that. It is too much effort. You will, or they're quite big to be able to deal with such a thing. They'll employ a quantitative surveyor or something to work out all this stuff. But this does get into this problem that this isn't, it's still not an industry standard, everything yet, these ideas, even though they're, the technology is new, it's not that new. It's, and it's developing all the time. I think the key to this is if, like I said earlier, if some of this stuff became like a standard or like a, what is called a typical detail, and yeah, as to finding builders or I don't know. We often find we're up against the same 4 or 5 going for very similar projects. Different builders, that is.
I think that what I've been doing is getting the QS to cost it first.
Yeah, well that's the other way.
And then you can actually, you just choose the builder you like. You don't go out to tender, because I went out to tender, 2 years ago, and one dropped out. I was constantly trying to pick up another tender, so we had 3 to compare with, and it just took months. So yeah, I just say there's something in my quote that says we'll get the QS to cost it, and then you take out the numbers and you hand that out to the you interview some builders, you see who you like, and then you've got stuff to compare.
So the builder, you can't just willy-nilly go for it, because it might be wrong what the QS has done, or you might think you can't afford that or whatever. So and then you're in a contract, so you would go for a JCT or something like that, so there's a contract law there, so if someone's actually signed that, they need to deliver on that. So it does again mean that there's more sort of administration. Normally that's an independent person, so it would be the architect would administer it, or they're in the middle kind of thing. And that's how it all kind of works. Again, does cost a little bit more money than you running it yourself, but a complex project, trying to run it yourself, we won't touch them with a barge pole anymore. Something that's sort of a large size, sort of anything around about 400,000 that's not with an architect looking after it, we won't, because it's so complicated for a homeowner to deal with. There's so many different elements on a project of that size.
And there's things that crop up halfway through, isn't there? You didn't know about it.
Yeah, and then you have to have someone who's independent or in between the two, an arbiter almost, and someone with the technical skills. So I presume that's what. Yeah, so.
Both of them.
Huh?
Both of them.
Any more questions?
Yeah, just a question. It's carrying on a little bit from a conversation I was having with Dave about his underfloor heating thing that you were doing in the hallway. It's something I'm sort of working at the moment in my house. It's 1920s house, and gradually insulating and putting a wet system in the floor, and I'm using solar PV and a solar diverter, the hot water tank, and I'm just sort of wondering if any of you've got any experiences of heat stores underfloor, because I've got an area about 10 square metres, and I'm thinking of using that as a heat store, the wet system going around it as well. I just wondered if it is something anybody's been working on or got any experience of, and whether it's worth trying or not.
Not in that sort of scenario. I was talking earlier with my business partner about using a heat store, and it's done in a cylinder rather than in the floor, because obviously your wet system is your heating. So it was being used in a heat store in a cylinder that's then used to preheat water going into the air source heat pump to lower that. So that's coming from the PVs and then coming through that way. That's the only example I've got of that. But a Heath Robinson type thing, let us know how it goes. One of my clients built his own Tesla battery, and he was off grid for 3 months. So it's
Well, I've been using a solar diverter on my PV system. Most people use that just for hot water, but I've been using it for underfloor heating. and I've got a sort of cheap rates nighttime tariff as well, and it doesn't work too badly. So it'll work. I basically don't need to turn the gas central heating on with temperatures above 5 or 6 degrees. External temperatures above 6 degrees. So this winter the heating's had to come on when it's been down freezing, but apart from that, just about copes.
Fantastic.
So it's just interesting trying these things out.
Okay, so it's 2 minutes to 8. Any more burning questions before we finish up? We hope, Steve has been very kindly videoing this, so we hope that we can, and Rolf, who was going to be here tonight, is going to edit the video. So we hope that we can come up with something that really represents what's gone on this evening. And there will be, at the end of the video, there will just be links to the various people on the panel. If Rich and Mary are okay with that, but certainly the rest of you. And any questions you want to ask, I think, that come up afterwards, maybe just send them to transitionworthing@ttworthing.org. And we're hoping a bit later on in the year to have some Q&A sessions on Zoom with some of the householders. So do look out for that. That will be announced in our newsletter. We send out a monthly newsletter. So if you want to keep abreast of what we're going on, just go onto our website and sign up for that newsletter. It doesn't cost anything and there's no obligations at all. So thank you so much, all of you, panel and Sarah, for coming along this evening. It's just been really, really helpful having you here, and hopefully it's been an interesting and inspiring evening for everybody, and thank you for coming along.